find the total surface area of the composite solid below, do not include the base of the cone. We have a cylinder and a cone. And now what I'll do in this case is work from left to right and write down the name of the first three-dimensional shape, which is a cylinder. Okay? So I know I'm working with a cylinder plus cone. And I'm going to total surface area looking for cylinder. So I'm going to put down 2 pi RH plus 2 pi r squared. And that's for the cylinder. My cone here is total surface area for the cone. Now this is what's confusing about composite figures, is that now we have to manipulate the formula to make it work with this figure. It says do not include the base of the cone. Well, here's the base of the cone. Now you know when you look at the formula chart under area, the formula for a circle is pi r squared. It says do not include that in the cone. So I need to cross this out. Don't use that. So if I take it out of this, notice I must take it out of the cylinder. So the pi r squared, see there's two of them here for the two bases, but I need to take it out. So I need to take it out of both. So instead of having two, I'm only going to have one. So we need to turn this number 2 into a 1. There's only going to be one base, and that one base is this one right here, because this one here is the one that would be exposed to needing paint, that sort of reason. So make sure you turn this into a 1 or just cross out the 2, leaving just pi r squared. It says let's use 3.14 for pi. And let's start replacing all the letters, and we'll stop and come up here and work what we need to work to find the missing letters. So I'm going to go ahead and write down 2 times 3.14 for pi r. Okay, r is half the diameter. Notice we have out here this segment that's going the entire length of the circle. That's going to represent the diameter. Okay, so the diameter is 4. That means my radius is 4 divided by 2, which is 2. So I now know, and I'm just going to be working right here because it already has a little segment that represents the radius, and I go ahead and put 2 here. And this 3 here is representing the height of the cone, and that's important to understand. And here's my 90. You should be thinking of Pythagorean theorem because we need the slant height here as well. So I know that r is equal to 2. I've got to find slant height, which can be found. You remember that if you take the square root of the legs, square them, and add them, you can get the slant height, which is the c. 2 squared plus 3 squared. Okay, this is, you can see that if I kept it as the square root of 13, I will keep all those decimal places. So that's 4 squared plus 3 squared, that's 4, that's 2 squared is equal to 4, plus 3 squared, that's 9, 9 plus 4 is 13. Alright, or you can first, just to make sure you're using a decimal, what is going to round to 3.6 just for saving paper space. But we need to use all those decimal places or keep it as a square root of 13. Now come back down here. We know the radius is 2. Remember, the height of the cylinder goes from the circles, from one circle to another circle, which would be the same distance up here, 3. So this is the height of the cylinder. Height is equal to 3, so I'll bring that down here. Now bring down this plus sign, and I don't need to bring the 1. It's automatic now. I could just replace pi with 3.14 times radius. We know it's 2. Square that. Don't forget to square. Bring down the plus. Replace the pi here with 3.14 times the radius, just 2, times slant height, square root of 13. If you do the square root of 13, you will get all the decimal places. You can follow me here. 2 times 3.14 times 2 times 3 plus 3.14 times 2 squared. And I'm just up here topping all this in. Plus 3.14 times 2 times. Now, if you had turned yours into a decimal, right, you can arrow up and get all those decimal places. All right, that's important. Look at all these decimal places. Now, when you press enter, you round here at this time. So this would be 72.9. Okay, so the total surface area is 72.9, and we have no units, so such as inches, meters, centimeters. So when that happens, we'll just put down the word unit squared. Okay, units squared. So whatever units of measurement that is used would replace this word unit.